really great to see everyone.
Good morning, and welcome to the first edition of ExaConf. And I welcome you to the post-PC era of Web3. We have some really exciting announcements for you today. Technology breakthroughs that will make the current Web3 mobile first. When Satoshi Nakamoto laid the foundations of Bitcoin, it was very clear from the start, Bitcoin will be built for the people and maintained by the people. Bitcoin provided pseudonymity, security, and decentralization. This ignited the Web3 revolution. We call it the 3 principles of Web3. Fast forward to today, we feel that some aspects of these 3 principles have been diluted, especially decentralization. It is no longer possible for people like us to maintain the Bitcoin network, as it requires a huge amount of compute to do it. This has resulted in shift of power to people who own large mining farms like these, and in total, the performance required to mine the next block is upwards of 15 exahash per second. Compare this to a PC with a performance of just 5 megahash per second and a mobile of 5,000 hashes per second, you just cannot compete. And even if you tried, it will take upwards of 2 years to mine the next block using this laptop. Staking consensus in certain layer 1s are no better either. They demand a huge amount of crypto assets to be eligible for mining. You need upwards of $4 million worth of crypto assets to be eligible for the mining. This has systematically created barriers for people like us to maintain the network and earn crypto assets the right way. With Exa Protocol, we envisioned to change the current Web3 world order and to bring power back to the people to maintain the networks. Before it can happen, we have identified 2 major roadblocks. First, there is a high reliance on PC hardware at the moment, and there are no equitable consensus algorithms. Some demand a huge amount of compute, and some demand a huge amount of wealth. Now, when you start from a PC-first approach, you create software that works and scales on PC only. The PC software can work both on a small laptop and on a huge mining farm. Since there is no equity in compute, it was inevitable that the power will ultimately shift to people who run huge mining farms. This, we believe, is a fundamental flaw with the current layer 1s. So how do we solve this problem? Well, we can start by removing the need for a PC in the first place and use a mobile phone instead. Sounds crazy, but mobile phones of today are as capable as a PC from just 2 years ago. It is about 1 million times faster than the guidance computer that sent people to the moon. And most importantly, it offers equitable compute. That is, there is a limit to how much compute a phone or a node can provide. There is no phone out there that has a power of a server farm. Finally, it is decentralized by nature. Everyone owns a mobile phone. With this, we started Exa Protocol, and after 2 years of research and development, we are going to introduce the world 3 major breakthroughs that will make the Web3 mobile first. First, an infrastructure app that allows you to store and retrieve your data from a decentralized network built using mobile devices. And we are calling it ExaDrive. Second, an ERC20 token through which we compensate the users for sharing their storage on the ExaDrive app. And third, a breakthrough layer 1 that runs natively on mobile devices. And we are calling it Darwin. We are talking about bleeding-edge technology here. And to talk further on this, let me welcome Arpan to introduce us ExaDrive.
Hi, I'm Arpan, and I'm excited to show you something which changes how we look at the applications of blockchain. Somewhere around the second half of last year, I reached the limit of my free cloud storage or drive storage, even though I had some good chunk of storage available on my phone. Since my phone has some free storage, this is effectively true for millions of mobile devices out there. So we asked ourselves this question: can the free storage of all these phones be used like a cloud storage? We thought deeply about this problem and created ExaDrive. It allows you to share your phone storage on the Exa network and also allows other people on the network to use it. And here we are today with ExaDrive, where you can get practically limitless cloud storage, which is by default anonymized, encrypted, and decentralized. And what more, you also get rewarded for being a good storage partner through our native token. How does it work? There are 3 layers: the mobile device acting as storage unit, the caching server, and the user agent. The user can use the ExaDrive through an app on their smartphones. Once you fire up the ExaDrive app, it will ask you to allocate how much amount of storage you want to offer to store files. And then if I upload the file to Exa network, what happens? Let's take a look at it. First, on-device encryption. Yes, the user who's sending the file encrypts it using AES-256 encryption by using a private key. Then the file is sent to the nearest caching server. The caching server then checks the file integrity using proof of space and time, which is POST, to verify the file integrity in the future. Then the file is broken down into different shards, and each shard is sent to different mobile devices across the network. You might be thinking, what if I need the file and the phone or the device which has that particular shard is turned off, thrown away, destroyed, or is out of network coverage area? Well, this is where we introduce redundancy factor. We let you choose a number which is a redundancy factor, which means on how many mobile devices each shard will be duplicated. Now comes the most important part. I want to access my file. Well, all I need to do is select request from the app. It'll tell the nearest caching server to find all the shards, stitch them together, and send it back to the app. Now it's the time for a demo. Yes, we are demoing the app today, and it is super duper exciting to show you what we've built. Let's move to the demo. Now let's start with the home screen of the ExaDrive app. There is a list of all my files which I've uploaded to the drive. Next is the settings. I'll go to add files later. Settings has 4 options right now. The first one is the redundancy factor, which we just discussed. What is the number of shard duplicates that you want to create? Second is how much storage you want to allocate to the DFS. Third is to allow DFS or ExaDrive to be running only when your device is charging to save battery. And finally, do you want to make your files available offline? Yeah, that is also there. Let's go to My Files. Now let's choose a file to be uploaded. I am uploading this image, and yes, I've made it public. That is the checkbox you saw. Okay. Now let's click on the screenshot that was uploaded. You can see it shows an empty table showing shards and node ID. Well, it will get populated once it has been uploaded. Let's look at an earlier file which was uploaded. Okay, you can see that there is shards and there is node ID, right? Now if I look at one more file, there is a request option. If I request for it to be downloaded, the request is sent to the server to collect all the shards, bring it to one file, stitch them together, and send it back to the device. So I've opened another file, which is basically having a download button. If I click on download, the server will send the file, and it will be deleted from the caching server. That's it. The demo completes. Let's move on now. Now let's go to Naman to understand technically how developers can use ExaDrive in their projects. Naman, over to you.
Thank you, Arpan. Hi, I'm Naman. The last few months have been very exciting as we implemented the research to build the actual tech. But did you notice this public link button in the app which Arpan showed you? But before I show this button in action, let's go through the file caching. So caching is a state where a file is needed to be accessed from the server more often than other files. So the server stores it temporarily in its memory. A file is cached in the server when it receives a download request. After receiving the request, the server then talks to other mobile nodes where the shard is present. When the shards are retrieved, the server stitches those shards and saves in its memory. Now let's talk about what file security and what file security mechanism we are using. So we are using AES 256 encryption, which uses a private key that resides only with the data owner. So nobody except that data owner can decrypt that file. So let's do a quick demo of file caching and how the public links can be used by other developers in building their own projects. So here, I'm working on a portfolio website, and it requires some images. Earlier, Arpan uploaded an image and generated the public link. Let's use that public link and add it to our website. So this is our website, and as we can see, there's a placeholder over here. And let's replace this placeholder with an actual image. So for that, let's go to our ExaDrive app. So this is the file which Arpan has uploaded. And when I click over this, I can get a public link. So let's click on this button, which will copy this link into my Android clipboard. And now let's use this link into our website. So just let me paste it. Now, this is the link which we got, right? So let's check out this link right now. Oh, this is an image. So let's try to embed this link into our code, and let's see what happens, right? So let's go to our code, and let's paste it over here. Now let's see what happens. So if I reload the website, whoa, there you go. Now we have an actual image instead of placeholder. This is not just limited to storing data on the app. ExaDrive is built to power the web by providing cloud storage, class file retrieval. The files can be stored on ExaDrive and then integrated directly into your websites.
Thanks, Naman, for this demo. It shows how easy it is to use ExaDrive to power your websites through a network of mobile devices. Now it is possible to run the web through the power of a phone. Our app compensates the user through a token called XAP, which is an ERC20 token with a limited supply of 1 billion. Users who provide storage and transfer data on requests are compensated through this token. You can also use the token to use the storage on the Exa network. And finally, the one last thing. All along, we have been proving that mobile phones are enough to power the internet, or to provide the storage at least. But is it capable enough to run a full-blown blockchain? That is, can a mobile phone act as a full node? With the current layer 1s, it can't. And we took this as a challenge. After 2 years of research and development, today we are really proud to announce a layer 1 that runs natively on mobile devices. And we are calling it Darwin. Darwin is an evolutionary layer 1 chain that mutates to increase the TPS of the chain as more mobile nodes join the network. And to tell you more on this, let me call upon Arpan. Arpan, over to you.
Thank you, Saurabh. In the past 50 years, we've moved from room-sized computers to smaller than palm-sized devices, which can actually do more than those mainframes. But what happened in blockchain? To participate as a miner, we've moved from one machine, which was a laptop, to the size of a farm. Well, we went back and spent about a year on this problem, and today we introduced Darwin. Darwin models the real world's evolution into a blockchain which is mobile first. And what have we achieved with Darwin? Well, a mobile phone can now act as a full node, and we can achieve a massive TPS of 7.5 million at scale. Can you imagine that? Well, let's look at the features of Darwin. It's a layer 1 chain. It supports mobile devices as full nodes. And most importantly, it reduces the amount of energy spent on mining a block. Isn't that amazing? How is the architecture shaped up? It is a distributed tree architecture. A group of nodes start with the genesis chain. As it grows, this chain mutates into multiple child blockchains based on network latency, reputation of nodes, and a couple of other factors. Now, in Darwin, we have introduced 4 types of blocks: genesis, transaction, audit, and fossil. Let's take a look at what each of these blocks stand for. Genesis, the first block of the entire Darwin chain and the network. Transaction block is basically a ledger or a list of all the transactions, as usual as a normal blockchain. Audit blocks, very important to the chain, are used to verify the transaction blocks up until the last audit block prior to that current one. Then comes the fossil block. Well, you can also call it as a genesis block of the child chain. It holds the summary of all the previous parent chain from which this chain has evolved into. Let's take a demo with Naman.
Thank you, Arpan. I'll take it from here. So this is our Darwin app. This is what our home screen looked like. So we have our address button, which basically is our wallet address. Below this wallet address, we have 2 buttons, which is transfer and request. I can transfer or request XAP tokens from any wallet address. We just have to enter that wallet address, find that node, and just transfer that XAP token. Below this, we have list of our previous transactions. As of now, it's showing no transaction because I have not done any transaction as of now. But as soon as I do any transaction, it will be listed over here. I can see on the bottom right, there's a plus button, which has 3 options. First is request XAP, send XAP, and go to messages. So go to messages is a P2P messaging service, which basically I can directly talk to a person before sending XAP. Let's go to the second tab, which is global activity. In this tab, the first section is global live logger. So global live logger shows all the activity happening on Darwin network. So for example, our node just joined the chain few seconds ago. Our transaction was created few seconds ago. If we go further down, our transaction was created 1 minute ago. Below this section, we have activities listed into different categories, which is transactions, chains, blocks, and nodes. For example, in transaction, these are all the transactions which are happening on the network. If you go to chains, these are all the chains which have been created recently. If you go to blocks, these are all the blocks which have been created on our network. And if you go to nodes, these are the nodes which have joined our network recently. Now let's go to the third tab, which is My Chain Explorer. So in the My Chain Explorer, I can see the current chain address of my node. And I can also see total transaction which I have done till now. So which is 0 because I have not done any transactions. Below this, we have another section, which is Global Explorer and Chain Explorer. So this is how our entire Darwin network looks like. And this is how it has mutated over time. You can see a white dot over here. These white dots represent a chain and how it has mutated from a particular chain over time. Now let's go to My Chain Explorer. In My Chain Explorer, I can see my chain. So this is my chain and this is my chain address. And I can click on this address to see more information about my chain. So these are the information, these are all the data of my chain. For example, total nodes, the address of my chain, the parent chain address from which my current chain has been mutated, total number of transactions this chain does, total number of child chain this chain has, total number of blocks this chain has. And similarly, in the below section, we have all the activities categorized in different transactions, chains, blocks, and nodes.
Thank you, Naman and Arpan, for the technical introduction and the demo. The future of mobile-first Web3 is here, and we are entering into a post-PC era of Web3 today with ExaDrive and the phenomenal Darwin Layer-1. We are announcing the launch of our XAP token on 16th of April 2024, and you will be able to get your hands on them through various dexes. We'll announce the list very soon. You will be able to use ExaDrive in Q4 of 2024 and Darwin in Q2 of 2025. With that, thank you so much for joining us on ExaConf 2024, the post-PC era of Web3. We'll see you soon. Bye-bye.